students. In this module, we will be learning the differences between mass and weight. As we know, mass is the amount of matter contained in a physical body, and weight is the force by which Earth attracts any object towards its center. So, mass is the fundamental integral property of matter. Weight is not a fundamental property. Mass has magnitude but no direction, so it is a scalar quantity. Weight is a kind of force. It is nothing but the gravitational force of Earth. As we know that force has both magnitude and direction, weight also has magnitude and direction, so it is a vector quantity. Mass being the fundamental property of an object, it is independent of the location where it is measured. Wherever we go, any point of Earth, any planet, any satellite, mass of an object remains the same. But weight of a body depends on acceleration due to gravity, because W is equal to m into g, small g, where g is the acceleration due to gravity, and we have seen that acceleration due to gravity value varies from planet to planet, planet to satellite. On Earth, at pole and equator, the value of g is different. On the surface of Earth or at high altitude, value of small g is different. So, weight of the body may vary with the change in the value of acceleration due to gravity, but mass does not change. Mass is measured using pan balance, and weight is measured by using a spring balance. We have used spring balance in our SAC class. SI unit of mass is kg and SI unit of weight is Newton. Now, we have already learned what is weight. Now, weight is expressed mathematically with the expression W is equal to mg, where m is the mass of the concerned object and small g is the acceleration due to gravity. SI unit of force is Newton, so is the SI unit of weight. Now, what will be the weight of an object which has mass 1 kg? Let us put the values. By substituting the values of m and g, we get 1 kg into 9.8 meter per second square. That is equal to 9.8 kg meter per second square. So, W is equal to 9.8 Newton. So, weight of 1 kg of mass is 9.8 Newton. Let us solve some numerical problems on mass and weight. These numericals you have to practice nicely and you have to understand the concept very well. These are very easy and it is based on only a single formula which are very much known to us, W is equal to mg. But concept is to be clear. First numerical, mass of a body is 5 kg, what will be its weight? So, mass m is equal to kg, weight is equal to mg. In place of mass m, we are replacing the value of m by 5, 5 into 9.8, that is equal to 49 Newton. Be very careful here that unit of weight is Newton, it is not kg. Question number 2, what is the mass of an object whose weight is 100 Newton? In this case, weight is provided, we have to find out the mass. Let the mass be m, weight is 100 Newton, so W is equal to mg. So, 100 is equal to m into 9.8, mass is equal to 100 by 9.8, that means it will be 10.2 kg. Note down the value of acceleration due to gravity, if it is not provided in the question, you can take either 9.8 meter per second square or 10 meter per second square. But if a value is provided in the question, you have to use that value. That time you cannot use the other value. Question number 3. A man weighs 600 Newton on earth. What is his mass? Here the value of G is provided as 10 meter per second square. If he was taken to the moon, his weight would be 100 Newton. What is his mass on the moon? What is the acceleration due to gravity on the moon? There are 3 parts of the question. Now weight on earth is given 600 Newton. We have to find the mass. We have already done the same kind of sum in question number 2. So we are assuming the mass to be small m. Same formula we are using. W is equal to mg. So 600 is the weight, that is equal to m into 10. 10 is the value provided in the question. So mass is equal to 600 by 10, that is 60 kg. So mass of the object is found. But mass is the integral property of the body which remains same everywhere. Mass will never change. So mass of the object on earth and on moon will remain the same. So mass of moon will be 60 kg. Now they have provided the mass of moon in the question, that is 100. So weight on moon, W moon is equal to m into G moon, where G moon is the acceleration due to gravity on moon, which we have to find out. So we are substituting the given values. 100 is equal to 60 is the mass into G moon, or G moon is equal to 100 by 60, that is 1.66 meter per second square. So we have seen that the weight of an object is 1/6 on the surface of moon than on the surface of earth, but mass remains the same. Number 4. How much would a 70 kg man weigh on the moon? What would be his mass on the earth and on the moon? Acceleration due to gravity on moon is equal to 1.63 meter per second square. Mass m is equal to 70 kg. Acceleration due to gravity G moon is equal to 1.63 meter per second square. Here W moon is equal to m into G moon. So 70 into 1.63, which gives us that weight of the object, weight of the man on moon is W moon is equal to 114 in 0.1 Newton. But mass is the fundamental property of the body. So it will remain constant everywhere. So mass of the body, man will remain the same on earth and on moon. So the man will have same mass, that is 70 kg. At what place on earth is the weight of the body maximum? It is maximum at poles because W is equal to mg and value of acceleration due to gravity is the highest at poles because the radius of earth is the lowest there. So G is maximum, so W will also be maximum because mass remains constant. In the same way, at what place on Earth's surface is the weight of the body minimum? The answer will be equator because W is equal to mg and the value of small g is the lowest at equator. Now, why does a body reach the ground quicker at poles than at the equator when dropped from same height? The acceleration due to gravity is more at the poles than at the equator. So time taken for a body is less if the acceleration due to gravity is more, when the initial velocities and the distance travelled are same. So when it is dropped from the same height, a body reaches the ground quicker at the poles than at the equator. Here is one critical thinking question from NCERT exemplar. identical packets are dropped from two aeroplanes, one above the equator and another above the North Pole, both at height h. Assuming all the conditions to be identical, will those packets take same time to reach the surface of Earth? You have to justify your answer. So you have to think in the line of the value of small g, how it varies at the equator and at the pole. Accordingly, you have to write the answer. Now, equations of motion for a freely falling body. As we know that freely falling bodies fall with uniformly accelerated motion. The three equations of motion delivered earlier, what we have already discussed in the first chapter, so those are also based on uniform acceleration. So the same equations can be applied here to the motion of freely falling bodies. So for freely falling bodies, there are certain changes to be made in these equations. Instead of writing acceleration as a, we will be writing small g, because here the acceleration is acceleration due to gravity. And as we are talking about vertical distance, so s will be replaced by small h. Rest of the notations will remain the same. So the first equation will be v is equal to u plus gt instead of v is equal to u plus at. Second one, h is equal to ut plus half gt square. And the third one is v square is equal to u square plus 2gh. Here s is replaced by h. Now, while discussing the motion of freely falling body, we have to assume few things, that whenever a body is object is dropped freely from a certain height, then the initial velocity of the body will be 0 and the final velocity of the body just before touching the ground will be maximum. And when the body is falling down freely, then as because the body is accelerated, the value of small g will be positive because it is increasing. On the other hand, when the body is thrown in the upward direction with an initial velocity is maximum at the throwing point, and it will reach up to the highest level till its velocity becomes 0. So the final velocity will be 0 when the body is moving up. And as because the body is acted upon by the gravitational force of Earth, so it is decelerating. The velocity of the body will reduce and it will reach 0 at the highest point. So g value will be taken as minus 9.8 meter per second square. So when we will be doing the numerical problem, we have to keep these things in mind. Here are some numerical problems on freely falling body. The first one is, a stone is dropped freely in the river from the bridge. The stone takes 2 seconds to touch the water surface in the river. Calculate the height of the bridge from the water level. Here g is given by 9.8 meter per second square. Initial velocity of the stone u is equal to 0 because at the beginning point when a body is dropped and it is falling freely, u is 0. As the stone is falling down freely, acceleration due to gravity g is plus 9.8 meter per second square. Time t is equal to 2 seconds. As h is equal to ut plus half gt square, so h is equal to 0 into 2 plus half 9.8 into 2 whole square. So h is equal to 0 plus 19.6. So h is equal to 19.6 meter. When a ball is thrown vertically upwards, it goes through a distance of 19.6 meter. Find the initial velocity of the ball and the time taken by it to rise the highest point. Acceleration due to gravity is once again given, g is equal to 9.8 meter per second square. Look at the difference between the first sum and the second sum. In the first sum, the body was dropped and it was moving downwards, and in the second sum, the body is vertically thrown upwards. So in the first sum, initial velocity of the stone was 0. But here, as the body is moving upwards, it will reach up to that height till its velocity becomes 0. So we are taking that at the highest point of its motion, the final velocity v is 0. Initial velocity we are assuming to be u. And as the body is moving up, its velocity is decreasing. So the acceleration due to gravity is taken to be negative. G is equal to minus 9.8 meter per second square, unlike the previous sum. Here we are finding u. So we are using third equation of motion. V square is equal to u square plus 2gh. So 0 is equal to u square plus 2 into minus 9.8 into 9.6. So if you reduce and simplify, we are getting u is equal to 19.6 meter per second. Now, there is a second part of the sum. We have to find out the time taken by the body to reach the highest point. So, we are using the first equation, v is equal to u plus gt. Final velocity v is 0. Initial velocity we have calculated in the first part. So, instead of u, we are writing 19.6 plus small g value is negative because the body is moving up, minus 9.8 into t. T is the time. So, when we are simplifying, we are bringing minus 9.8 t on the other side, it becomes plus 9.8 t is equal to 19.6. So, t is equal to 19.6 by 9.8. So, time is equal to 2 seconds. Question number 3. A cricket ball is dropped from a height of 20 meter. Part A. Calculate the speed of the ball when it hits the ground. Part B. Calculate the time it takes to fall through the height g is equal to 10 meter per second square. Now, initial velocity u is equal to 0 at the highest point of the motion. As the ball is falling freely, acceleration due to gravity g will be plus 10 meter per second square. Note that in this sum, g value is given 10. So, we did not take 9.8. We have to use that value whatever is provided in the question. Height is equal to 20 meter. Let the final velocity be small v. So, we are using third equation of motion, v square is equal to u square plus 2gh. V square value we are finding, u is 0 plus 2 into 10 plus 20. The body is moving downwards, so g is plus. So, v square is equal to 400, v is root over 400. So, v value is 20 meter per second. Then again we are using first equation of motion, v is equal to u plus gt. 20 is equal to 0 plus 10 into t. T is equal to 20 by 10, that is 2 seconds. A ball is thrown up with a speed of 15 meter per second. How high will it go before it begins to fall? G is given as 9.8 meter per second square. Initial velocity of the stone u is equal to 15 meter per second. As the ball is going up against the attraction of earth, so its velocity is decreasing. Acceleration due to gravity g is equal to minus 9.8 meter per second square. Final velocity of the ball v is equal to 0 at the highest point. V square is equal to u square plus 2gh. So 0 is equal to 15 whole square plus 2 into minus 9.8 into h. 19.6 h is equal to 225. So h is equal to 225 by 19.6. So h is equal to 11.4 meter. Hope all of you understood the concept of mass and weight and their differences, and how to solve numerical problems based on freely falling body, and whatever be the difference between a body which is moving in the upward direction and the body moving in the downward direction. All these are understood by everyone. So if there is any difficulty in understanding, please discuss with us in your Teams class. Thank you, children.